Dear students, in this session we are going to see about the combination of capacitors. That is a combination of capacitors in series and parallel. First we will see the series connection. So let us see the diagram. There is a three capacitors C1, C2 and C3 are connected with the batteries. The three capacitors are connected in series. So that means one after another. So whenever we are solving the series problem, we should keep in our mind the charges in each capacitors will be same. So the amount of charge in C1 and the amount of charge in C2 and C3 due to the battery, that is a battery is connected, whenever the potential difference is applied, the capacitors gains the charge. So the charges on the each capacitors is same, but the potential difference on the each capacitor will be differ. This is for series connection. We should keep in our mind. So let us see that the three capacitors C1 and C3 as shown in the diagram we are connected. Whenever, that means when the potential and the charges are directly proportional. So Q is equal to CV. So C is a capacitance of the capacitor. So V, the potential, is equal to Q by C. This C is a total capacitance of all the three capacitors. That is, if you are adding, that is what is the total capacitance of combination of all the three capacitors in series, that is represented as CS. So as we already told that the charge is same and potential, the voltage is variable in series connection. So when by using this formula, for the capacitor C1, the charge is same but the potential is differ. The potential is V1. So we can write like this. So V is equal to Q by C. For capacitor 1, the voltage is V1. For the capacitor 2, the voltage is V2. For the capacitor 3, the voltage is V3. So by using the formula V is equal to Q by C alone, C1 means V1, C2 means V2 and C3 means V3. That is written here. So as we already know that all the three voltages, all the three potential difference is equal to total potential difference V. So V is equal to V1 plus V2 plus V3. So substituting this V1, V2 and V3 here, Q by C1 plus Q by C2 plus Q by C3. This V is a total potential difference, that is Q by CS. So Q by CS. So let me take the Q commonly outside, 1 by C1 plus 1 by C2 plus 1 by C3. So here the Q also taken commonly outside. This Q and this Q get cancelled, and finally we get 1 by CS, which is equal to 1 by C1 plus 1 by C2 plus 1 by C3. That means the capacitance connected in series, the total capacitance or the effective capacitance of the series connection is 1 by CS of 1 by C1 plus 1 by C2 plus 1 by C3. So very simple step. V is equal to Q by CS. So whenever the capacitor's value changes, the voltage value changes. So just to sum up all the voltage, we get the equation. Similarly, for parallel connection. So for parallel connection, we should keep that the charge is variable and the potential difference is same. So charge is variable, potential difference is same. So this is a circuit diagram which shows the capacitor C1, C2 and C3 are connected in parallel with the battery connection with voltage V, total voltage V. Here the voltage are same for C1, C2 and C3. The what is the potential difference? It is the same, but the charges are different. For C1 the amount of charge is Q1, for C2 the amount of charge is Q2 and C3 the amount of charge is Q3. So as per the formula Q is equal to CV, then Q is equal to CPV. But that means the CP is a combination, the effective, the total capacitor value or effective capacitance value when the three capacitors are connected in parallel. That's why we are put the suffix P. For series we put the suffix S. So let me see that. So Q is equal to CV. For capacitor 1, it is a Q1 C1V. That means the voltage is constant. As we are earlier, we are saying that V is the same, potential is same. So for C1 capacitor, charge is Q1, potential is same. For C2 capacitor, charge is Q2 and potential is same. For C3 capacitor, charge is Q3 and potential is the same V. That is this equation we get. As it is, the total charges is equal to Q1 plus Q2 plus Q3. Just to substitute Q1, Q2 and Q3 here, we get C1V plus C2V and C3V. then what is the total charge? The total charge is written as CPV, the total capacitance into voltage. So let's we take the voltage commonly outside, then this side and this we will be get cancelled. Finally we get Cp, which is equal to C1 plus C2 plus C3. That means if the three capacitors are connected, if n number of the capacitors are connected in parallel, the total capacitance value is merely simply the addition of all the capacitors. Let us see one example. So we take it as the capacitor C1 value is 1 microfarad. So already we have studied that the capacitance is a ability to store the charge in the parallel plate capacitor. So the SI unit of the capacitance is farad. The farad is a higher value. So we will measure in the microfarad or millifarad. Here the capacitor C1 has a 1 microfarad value and C2 is 2 microfarad value and C3 is 3 microfarad value. So let us we do the combinations in both series and parallel. So what is the formula for series combination? Yes, 1 by Cs, which is equal to 1 by C1 plus 1 by C2 plus 1 by C3. Merely substitute C1, C2 and C3. We get 1 by 1 plus 1 by 2 plus 1 by 3. So taking the LCM, we get 6 plus 3 plus 2 by 6. So finally we get 11 by 6. So the students are merely put that the total capacitance value is 11 by 6. So that is wrong, because we are taken in the formula the reciprocal of the total capacitance is the formula this one. So we have to take the reciprocal. If you take 1 by Cs, which is equal to 11 by 6, means Cs, which is equal to 6 by 11. By solving this number, we get the answer 0.545 microfarad, because all the capacitors are in microfarad value. Let us see that what is the same capacitors are connected in parallel. Oh, it is very easy, because Cp, which is equal to C1 plus C2 plus C3. So 1 plus 2 plus 3. Finally we get 6 microfarad. So what we will understand that, so when the three capacitors of the same value, that means it is connected in series and parallel, but the capacitors values are same only. So when it is connected in series, the total capacitance value is less than that of the lower capacitance value in the combination. So again I will say that when the capacitors are connected in series, the effective capacitance or the total capacitance of the series combination value is less than that of the lower capacitance value in the combinations. That is, it is less than the lower value. You see that these three capacitors, very lower value is 1 microfarad. For series combinations, the total value is less than 1 only. Also, when we are connected in parallel, the total capacitance when the three capacitors are connected in parallel is, it is the final capacitance, that is the total capacitance or effective capacitance is greater than the higher value of the combinations. That is the simple methodology. So whenever we want to increase the capacitance value, we have to connect the capacitors in parallel. When we want to decrease the capacitors value in a circuit, we have to connect the capacitors in series. So in examinations or in the question paper, they may ask that find the total capacitance or effective capacitance or equivalent capacitance. All these things represent the same value. That is, it is in parallel means Cp, it is in series means Cs. Again I will remind you, don't forget to take the reciprocal by doing the calculation in series combination.